So the trunk that's sitting on a driveway, it's incline and angle. So if we have, this is our driveway, okay, and this is at a certain angle, and here's our trunk. What direction is the weight of the trunk? Downward, straight down. So here's our weight. What direction is the normal force? Straight up? It's perpendicular to the surface now. It's always perpendicular to the surface. But when we're on an incline, it's not it's not opposite the weight anymore. It's not straight up. So we're going to have to look at some of our problems here, okay? So here's the picture. If we have an inclined plane, we're going to rotate our x and y axes. So now x is parallel with the inclined plane and y is perpendicular to the inclined plane. Okay? And so now we have our weight, and we're going to split our weight in the y and the weight in the x. And then I just moved it up here because it's acting on the box or the crate or whatever. But it would be right here also, same magnitude. And since these are, they have two triangles with mutually parallel or perpendicular sides, they're similar triangles, you're going to break them into components and then calculate it, and they are similar triangles. So this angle right here and this angle right here are going to be equal to each other.
Do you have an extra sheet thing?
I don't. So we're going to do a lot of the same sine, cosine equations, but these are specific to the weight and normal force. Now, our f of y, we have the normal force in the y direction. We also have the weight in the y direction, and it's not moving off of the surface, so then that is equal to ma, but acceleration is 0, so it equals 0. So we could solve here for the normal force. Our x forces, in this case, there's only wx. So we're going to have this. And that is all equal to ma in the x direction. A lot of the same stuff that we did already, just in a different situation. Can I switch it? So if we do a problem here, a trunk weighing 562 newtons is resting on a plane inclined at 30 degrees from the horizontal. We're going to find the components of the weight parallel and perpendicular. So actually, let me get a new 30 degrees, 562. So this is our inclined plane right here. And this is 30 degrees. So what we're going to do is be able to break this into components. So this would be wx and wy because we've flipped our axes. So we have x here and y here. So once find the components of the weight parallel and perpendicular. So they want to know wx and wy. What is this angle right here? 30 also, right? These two angles are equal to each other. So to find wy, we'd have, that's the adjacent, right? So we'd use cosine. Cosine of 30 is equal to adjacent over hypotenuse Oh, I actually put 30 in there, so let me put the 562. And then WX is sine. What? That's our weight, not a mass, right? It says it weighs 562 newtons. Right, if it gave us the mass, we'd have to multiply by 9.8. So what is WY? 0.7. And WX? So now, could we find, well, what's the next problem saying? Okay, so the 562 Newton trunk is on the frictionless plane inclined at 30 degrees from the horizontal, so the same picture, same information here. Find the acceleration of the trunk. What direction is that trunk going to accelerate? Down the inclined plane, right? And so I'm going to move this WX down here, up here, I mean. And we're going to accelerate in this direction. How would we find the acceleration? We're going to have to sum up the forces in which direction? X direction. And what do we have? WX, right? Do we have any other forces in the X direction? No. So that's it. And what does that equal? MAX. And what's our mass?
What was that? Or was it NG? I don't know why I thought it was NG last time.
Yeah, that's weight. That's because we took the weight 562 times sine theta to find WX. What was the mass? Yep, divide by 9.8, and what is 562 divided by 9.8 is
57.35.
So we have WX is 281. We have the mass of 57.35. And so now we can find the acceleration. $4.99. Oh, 4.9. There we go. Questions on that one? A lot of the same type of equations as when we're pulling with an angle. Pulling an angle. The next one is that it changes the angle to a 66-degree angle. Calculate the values of x and y components of the weight, and how do they compare on a 30-degree angle? Well, should WX get larger or smaller?
No, larger.
Should get larger because the new, basically if we drew a new inclined plane, it'd be like this, right? So more of it should be in the x direction, in the y direction, right? Oh, yeah, I have my y, yeah. So now, what would WX be? Be 562 times sine of 66. 513. So 513. And WY So you would do the same type of idea, though. Okay. This is the one we just did. Okay. Thank you.
See you later.
Yep. So a car weighing 1.2 times 10 to the 4th newtons is parked on a 36-degree slope. Find the force causing the car to roll down the hill. So is that going to be perpendicular or parallel to the inclined plane?
Is yours perpendicular to the hill? Is that like on the inclined plane or against the ground itself, against a level surface?
Like if it's sitting on here, what's the force that it exerts perpendicular? So it would be WY.
Oh.
That's what they're looking for. Is it a 36? And that's 1.4, no, 1.4? 1.2. That's W. So the first one is find the force that causes the car to roll. Oops. Is that going to be WX or WY? What direction is that car going to roll? It's going to roll down this way, right? And that's due to WX. So WX is what? This again is 36 degrees, so we're going to use sine, right? So we'll take our weight times the sine of 36. $7,053.
That's what it is.
And that would be WX, right? That's the force that's causing the car to roll. And WY, the force perpendicular to the ground, would be 9,708.2. Good. And then does it have... Okay, the next question says, the brakes of the car fail when the car starts to roll down the hill. Assume there is no friction. What's the acceleration of the car? How would we find the acceleration of the car? Like that. And we found WX was 7,053. What's our mass of the car? I'm going to have that divided by 9.8, right? We'll put the 0.6 in. So this is equal to 719.6 times A. And
I got 1,224.
oh, you use your weight. The 1,200, 12,000.
Oh, I think you said 7.
You use WX instead of the full W. Okay, so what'd you guys get? 1,224.5. So then, what's our acceleration? 5.76 meters per second squared. Good. And then, let's see. After the bus has moved 30 meters, how fast is it moving? So the initial velocity is what? 0, right. So I think we can use this, right? Can't we?
Because we have to know.
Oh, we don't know time. Okay, we can't use that one. We don't know final or time.
So it has to be VF squared equals, no, because that one has T. Don't they all have T?
What's the other D equation?
D equals, see, VIT, we don't know T. Oh, it's T.
So we can't use that one either. There we go. So now we're going to solve for VF. So, and this was 0. Our initial is 0. So VF is equal to the square root of 2A is 5.76. And then D is 30 meters, right? Isn't that what they say? Okay. So what is our final velocity? 5.88 meters per second. Yep, there you go. See how we can tie all that stuff from chapter 2 or 3, whatever that was?
Yeah, I got 18.6.
Is that what you got? 18.6. Okay. That's why it's good multiple people. What?
Keep going on this.
Yeah.
See if we can get through them all today.
Yeah. So questions on the inclined plane? And then we're going to add friction to it. The only thing that's different is we know this box is going to be moving down the incline, unless you're pushing it up. But it's just naturally it's going to move down the incline, so the force has to be opposite the movement. So force is going to be going up the incline. Because friction slows down your motion, right? So if it was in the same direction, it'd be a force in the same direction of movement and make it speed up. So you went opposite. Friction what? Yeah, friction makes it slow. Yeah. Let me. Oh, cancel. I'm gonna change my pink into, because we're missing something here. We're missing normal force. Let me draw that in. Oh, that's a horrible line. Horrible too. Oh, I think it's I think I'm out of Kleenexes. Sorry.
Normal force is the same as WY, right? Just in a different.
In this case, yes.
Is WY perpendicular?
Yes, but WY is also perpendicular.
Will it not always be like that?
For this case, because our net force is in the y direction, the only ones we have normal force up, and we have weight down. We don't have anything else in the y direction, do we? Mm-mm. And that's equals 0. So then if normal force is equal to WY, yep.
Are we going to change that later?
Well, it all depends, like, when we were pulling at an angle, they weren't equal to each other because we had that Fy in there too, right?
So
In inclined planes, we should always, that should always be it.
it should always be equal.
Mm-hmm. Because really, I don't know if you'll ever have another Y force.
What happens when you're pulling it up?
Yeah, but I guess if you put a pulling force at an angle, usually.
But you have to like split it into components like you were asking.
So if we put like a pulling force like this, then you would have to add these forces in with it. Yep. A lot of times when you're pushing an inclined plane, you're pushing more parallel though with the surface, or pulling parallel a lot of times. So this is kind of what we just talked about right here. Our y forces, normal doesn't change. But this time, instead of just the x direction, the weight in the x direction, we have wx minus wf equals max. Whoops. So it's all about just looking at the picture, what direction our forces go in. And can I switch it now? So if a coin is placed on the book of a cover and just begins to move when the cover makes an angle of 38 degrees horizontal. So up until that point, it's not moving, so we're using static coefficient of friction. And let's, let me go. We don't know. Let me change to black. Let me draw the picture. $38 degrees, right? And we have this coin here. We don't know anything else, right? We do know weight is equal to mg. We know wy is equal to the cosine, right? Cosine of 38 times the weight, which weight is mg. We know wx is the sine of 38 times the weight, which is mg. And we want to know the coefficient of static friction. So we want to know the coefficient. So what's our force of friction is equal to mu times the normal force. And we know the normal force is this direction right here. So the normal force was equal to wy, which is equal to, I'm going to put the mg at the front, mg times the cosine of 38, right? Weight. You could put weight. We're going to need it as mg, you'll see. Okay, so we know normal force. Are we accelerating? Because we aren't moving, right? The coin isn't moving. So our net forces in the x direction, we have, that's just when it starts to move. So at 38, that's where we're still using static friction. Minus f of f, this time it's equal to 0 because we're not moving, so acceleration is 0. So wx is equal to f of f. So the force of friction is equal to mg sine 38, correct? So now if we plugged all that in here, we'd have mg sine of 38 equals mu times mg cosine of 38. What can we do?
So the coefficient is just sine of 38.
Well, mg's can cancel out, right? So then if we have the sine of 38 over the cosine of 38, is this the coefficient? And that's all you have to do. So we don't need the weight on that one. I guess for this one we could have left w in there because you could have crossed out w. There'll be some where you don't want to, but for this one you could. Does that make sense? A little tricky, but okay. Let me just have one more. The roof of a house rises 1 meter over horizontal distance of 1.5 meters. A 71 kilogram roofer stands on the roof. Is the frictional force that keeps the roofer from slipping equal in magnitude to Wx or Wy? And what is it saying? Magnitude. It would be Wx because it's the frictional force that's keeping him from slipping. If it was frictionless, there's no way you could stay on the roof. So it's the opposite direction of Wx, the frictional force. So it's equal in magnitude to Wx. And what's its magnitude? What do we know here? You found the angle? 16. You use tangent, right? Inverse tangent, yep. Okay, so now we have a roofer standing here. Say his weight was 71 newtons. And so what is Wx? Times the sine of 16, right? Because this is going to be 16 also. What was it? 19.46? 06? Like that? Or just 0.6? Oh, okay. There we go. So since he's not moving, we could go through and find what the coefficient of friction is. Because we could find the normal force is equal to Wy. Force of friction is equal to 19.6, and we could find the coefficient of friction that way. That's another problem we could do. He's not moving.
So the frictional force
is equal. Yep. Okay, questions on any of those notes?
How do you know magnitude?
Of
Oh, that's Wx.
Yep.
I was a lot
What?
easier.
You would take force of friction, which is 19.6. 0.6 is equal to the coefficient, and then the normal force would equal Wy, which is 71 times the cosine of 16. 68? Okay. So then you could find your... Is it in kilograms?
Yeah.
71 kilogram roofer. Shoot.
All I have to do is multiply that by 9.8.
Right.
So you have to know kilograms. Magnitude.
So it's 609.
192.
Should be 696.
Well, 19.6 times 9.8.
Yeah. You would... Since you're multiplying everything, you could just multiply that 19.6 times
Oh, I just
9.8. And you got 160...
192.
192. 192. Yeah. So then that changes this to 192, and that changes this. That would change this value, whatever that is. Shoot. Okay, questions? Yes. But we have since we finished the notes, tomorrow you'll have all day to work on this. And if you get done with this, you can work on your chapter review even. How about we change this to, oops, sorry. How about this will be due maybe, well, I'd like to say at the end of the period tomorrow, but we'll see. Okay?
Tomorrow at the end of the period.
Yeah, but you'll have the whole period to work on it.
Yeah, but we usually have 30 minutes because we stop. It was not today.
We'll see. Maybe it'll still be Wednesday before school. We'll see how well you work tomorrow.
Should they put your flag up though?
What?
They put all the flags up in the
In the what room?